In this example, you would like to calculate shear force and bending moment for the given beam. The beam is like this one. On the left side, the point A, we have a pin joint, and here roller is attached. That means this point at this point we have rotation is free, but movement in x and y direction, horizontal and vertical direction, is not free, is fixed. At this point, movement in horizontal direction is free. Of course, the rotation is also free. There is some distributed load like this one. The Q is 6 kilonewton per meter. That means Newton per meter is unit. Okay. And concentrated force P is given like this one, 28 kilonewton. Of course, some dimension, this dimension 5, 8, and 2 is given like this one. In order to find shear force and bending moment for this case, at first the strategy is to find reactional value RA and RB. After that, we can divide it into three parts. On the left side, when x is located here, let's say this, in this area, and when if it is located in this range, the second one, and finally on the right side, if it is located there, then we can consider shear force and bending moment. Okay, let's do it step by step. At first, let's assume it's not convenient to deal with distributed loads. But in order to find RA and RB value, reactional forces, then we assume the forces, distributed forces A to this point. This point is acting in the middle. In the middle. This one is 8 meters. Then maybe somewhere here is acting as equivalent concentrated force. This was Q is multiplied by total length is 8Q. 8Q is located like this one. Of course, the position is in the middle. Let's say this distance is what? 4 meters. 4 meters. Next one, when you consider this portion is what? It's also acting like this one. Then is this distance is 2 meters, and 2Q is acting like this one. Then we can calculate easily RA and RB. Okay, let's think about force equilibrium. Sigma F equals 0. Then upward direction is positive when you consider RA, and minus P, and this one 8Q minus direction, and upward direction RB, and downward direction 2Q. Okay, here P and small q is given. Then unknown is RA and RB. Okay, in order to find RA and RB value, we require another relationship. Then we can apply moment equilibrium. Let's say at this point A equals 0. Then when you think about this one, first, then minus P multiplied by length is 3. Next one, this one is direction is minus, because we considered counterclockwise direction is positive. 8Q is multiplied by 4. This distance is 4. Okay, next RB we can consider. RB is positive plus RB, and the length is 8. And next equivalent force, distributed force, is 2Q. Direction is minus 2Q. Length is 8 plus 1. 8 plus 1. This one. Okay, we can find here RB value, and if we know RB, then you can also calculate RA value. By applying force and moment equilibrium, we can have RA and RB value. Next, I've already told you we can divide it into 3 parts. First part, when x is less than this distance, left to concentrated force 3 to 0 in this location. When you draw free body diagram for this case, when you draw free body diagram like this one, then this point is A, let's say. This one is what? RA. Okay, you can draw this kind of distributed force, then you can say this distance is x. And you can introduce downward direction is positive v, and moment, counterclockwise direction is moment. Of course, this one is q, and it is acting in the middle, equivalent to q, let's say x. Qx is acting in the middle. Okay, then we can calculate shear force and bending moment in this case. At first, let's think about shear force. Let's say the upper direction is positive, then 0. RA value, RA is positive, and this one minus Qx, and downward direction is minus v. Then we can calculate shear force. Next, when you think about this one is positive for moment diagram, and you think about this point, then 0. At first, moment m is positive. Then consider this one positive Qx, and distance is half location x over 2. Rest of them minus RA, x equals 0. Okay, then we can calculate RA is known, then we can calculate moment m. Moment m is calculated. Next, similarly, when x is located in this region, secondly, x is located 3 to this length 8. Then you can draw free body diagram like this one. On the left side RA, and here P, and let's say this distance is x, let's say, and equivalent force 8q is located like this one. 8q is located like this one, and the downward direction v, and moment is acting m, like this one. We thought about here, somewhere here, right? Then we can calculate shear force and bending moment as well. Okay, in this case, when you apply force equilibrium, force equals 0 upper direction, then RA is positive, and minus P minus 8Q, and minus V. This one is 0. And let's think about this direction is positive moment equilibrium. When you apply, then when you consider at this point, V is deleted, M is positive, and plus 8Q, and this distance is located 4, and x minus 4, and next P is like this one, plus P length. This length is x minus 3, and finally this one is negative, RA, and total length is x is 0. Then we can find what here? Moment. Because we know p value and RA and everything, then we can calculate moment and shear force in this case. Okay, now let's consider about final one. When you draw free body diagram, the final case, when x is located somewhere here, then when I draw free body diagram like this one, on the left side and somewhere here, RB, this one is RA, RB, and P is acting like this one, P, and this one is 8Q. Of course, this length is what? Let's say X. And some force is acting here, some value. Okay, this one is later on I'll discuss again. Anyway, this downward direction is positive V, and this one is moment. Okay. We can say this one is 8Q is okay, fixed, because, but this value, 2Q, this value is different because this length is changed. Actually, let's say this one is, let's say, QX, let's say. The QX is calculated like this one, QX is what? X minus Q, distributed load Q is multiplied by Q is what? This distance, X minus 8. X minus 8 is QX. Also, its length, this distance is what? Distance is what? It is located in the middle. That's why the length is what? Half x minus 8. This length is what? Half is what? Is divided by 2. That's length. Here we can also apply the relationships. Force, equilibrium, and moment equilibrium. We can apply both of them. Okay, I separate like this one. Okay, that's case 4. Case 3, in case 3. When x locates 8 to 10 in this case. Okay, when you apply force equilibrium, it's not so difficult. Maybe you can write down positive upward direction is positive, then RA minus P minus 8Q and minus QX and minus V. Then you can calculate V value. Okay, when you apply the moment equilibrium, moment M, let's say this direction is positive, moment M, and V is deleted, QX, and this distance is the same as this one, x minus 8 over 2. We consider this one. Next one, RB, plus, not plus, minus value, sorry, minus, because we thought about this one, minus RB and this distance x minus 8, this distance. And when we consider this one, next one, this one, 8q is positive 8q, and the length, this distance, x minus this position 4. This one plus p is located x minus 3, and finally RA is minus value. RA is multiplied by total length x. Okay, we derived moment equilibrium. Okay, we can calculate here shear force like this one, and Qx is given like this one, and Rp is known here, and etc. Ra is also known there. Then finally we can calculate moment, bending moment like this one. Okay, in this example we've calculated shear force and bending moment in the beam. Okay, in order to find the shear force and bending moment, at first we calculate Ra and Rb value. In order to find them, then the distributed load is equivalent to concentrated load, which is acting in the middle of the component, each component. Okay, this distance is 8, that's why 8q is given there, and this distance is 2, and distributed load 2q is acting in the middle. Okay, in order to find reactional force Ra and Rp, we applied force equilibrium like this one, and we can calculate the Ra value. We can calculate this kind of relationship, and moment equilibrium we can apply there. Then we can find Rb value, and if we know Rb value, then Ra is calculated. We know Ra and Rb. Next stage, we want to calculate shear force and bending moment for each case, this range and the second range, and final another range. Basic one is shear force and moment equilibrium we can use in each case, here as well. This one here as well, here as well. And the important thing is how we can deal with distributed load. Actually, distributed load is acting in the middle like this one here or there. Well, finally here and here. When you thought about that kind of distributed load like this one, like this one, or like this one, then you can easily calculate shear force and bending moment for each case. Okay, that's for example of finding shear force and bending moments and the beam when you apply distributed load. In this example, you would like to calculate shear force and bending moment. The system is like this one. A beam is given. On the left side, pin, and right side, roller condition. And some distributed load, Q, is acting in the middle. But the size is different. On the left side is A, in the middle B, C is different. When A and C is same, it's symmetrically located in the middle. But here it's not symmetric. That's different point. And next, we would like to know shear force and bending moment in this case. In order to find that, our strategy is like this one. At first, RA and RV value find. And the next step, we separate the first range, second range, third range. Then we can calculate shear force and bending moment. Okay, let's do it. Let's do it. And here as well, this amount Q is acting like this one. Q is acting like this one. And in the middle, some equivalent QB, this distance QB is acting, where at this point is 2B, B over 2, this point. Okay, let's find reactional force RA and RB. Okay, let's say force equilibrium. On the left side, RA plus minus QB and RB. This one is 0. And next step, let's think about moment. Moment M equals 0. Let's consider at this point, let's say B. And RAL, and plus QB, and this length is B, this length, B over 2 plus C equals 0. Of course, we have some condition A plus B plus C equals L. We have this kind of condition. Okay. Then we can calculate RA and RB value. RA is given here, and the RB we can calculate. Okay, now we don't have any trouble to go further. Okay, at first we can calculate on the left side, but I will do not deal with this one. A bit difficult one is here at this position. When x, this distance is located, when we assume x is located A2, A plus B in this range. Then when you draw free body diagram, it's like this one. Let's say this point is A, RA is given like this one. Okay. Some force is acting like this one. And downward direction is positive, and counterclockwise direction is positive moment. This distance is, let's say, what? A. This distance is what? Let's say x. Okay, equivalent, this amount 1 is what? Equivalent concentrated force is Q is multiplied by x minus A, this length. Of course, it is acting in the middle. This length is x minus A over 2. This value, we have this value. Okay, then we are ready to calculate moment and shear force. At first, let's think about shear force. Upper direction is positive. Then let's think about this one is negative. This one, distributed force Q x minus A, negative. And plus what? We consider RA value. We know RA, and Q is given, then we can calculate the shear force. Then actually V is what? Linearly changed with Q is a function of x, V is a function of x, RA is a fixed value. Okay. Next, let's think about moment. Okay, let's see this one, this position. Then moment M, and this one is deleted, and the positive Q minus X minus A. This one is length is X minus A over 2. This distance is same. And we consider this one, next one RA. RA's direction is another direction. That's why minus value RA, and length is, total length is X. Okay, this one is 0. This one is 0. When you watch this one, this one, moment RA is fixed value, constant, and M is what? Some kind of second order curve. In this case, we can think of second order curve. Just case for this distributed rod. Here we found V value is order of 1, and M has order of 2. Function of X. Okay, in this range, linearly changed value, this value can be plotted, and second order term is given like this one. It is plotted like this one. Okay, if you have time, you can calculate on the left side and the right side. You can calculate. Then you can have linear constant and linear one. You can find it. Okay, anyway, when you calculate each position, each range, then you can have this kind of curve. This curve is shear force diagram. On the right, when you plot bending, the bending moment is changed like this one. This one is what? Bending moment diagram. We are very interested in the maximum value of bending moment. This one, maximum bending moment. Maybe this maximum bending moment can be happened when shear force is 0 or change this direction. This position is maximum bending moment. In order to find maximum bending moment, we draw shear force diagram and the bending moment diagram. Okay, you can calculate where x1 position is known. You can calculate this position. If it is equal 0, then you can calculate x equals 0. Then when you substitute this x position x1 here, then you can calculate maximum bending moment. Okay, in this beam, when maximum bending moment is known, then we are ready to calculate something further. What is it? Later on in next chapter, in next section, we can calculate what's happening inside the beam. That means inside the beam, we are interested in elongation or stress. If you know stress and elongation, then we can design the size of a beam. That's why we've calculated this kind of maximum bending moment. Okay, I summarize again for this example. In this example, this beam is given like this one. Distributed rod. And when you tackle this kind of problem, distributed rod is just like concentrated force is acting in the middle, like this one. And at first to find, reactional forces like this one. After that, when you think about 3 different range, in this scope, you can calculate when you consider in the middle, then X is located in this position, then you can draw this kind of free body diagram and apply force equilibrium and moment equilibrium. You can find shear force and bending moment. Finally, you can find bending moment and shear force diagram like this one, then finally we can have maximum bending moment. Okay, that's it for this example. Thank you.